All right, I guess we'll get started. My name's Warner Losh, and I'll be talking to you today about some of the experiences of different companies using FreeBSD in their commercial offerings. I'm currently with IX Systems working on FreeNAS, and in the past I've done a number of other projects to integrate FreeBSD. So before I get too much into that, I'll give you a little bit of background and context, tell you a little bit about how the project operates. This is necessary to understand the best way to interact with the project. I'll talk a little bit generically about the product lifecycle that most products go through and how that would apply to using FreeBSD in your product. I'll talk about the different tracking strategies that companies have used. Some of them very successfully, some of them not so successfully, sometimes with major pain, sometimes without. And then finally, a couple of these are fairly complicated to implement on your own. I'll talk about some of the subversion or the tools you can use to track them. Let's see. And before I get started, I've uploaded PDFs of my talk, and I have a companion paper that goes along with this that explains some things in detail. So I'm going to leave this up for a minute in case people want to jot down the URLs or grab them. And I'll have these URLs at the end of the talk as well if you don't get them before I take them down. And if you just go to _meet_BSD, there's the files you can grab. Okay. So what does it mean to use FreeBSD in a commercial environment? Primarily what I'm talking about today isn't using FreeBSD as an ISP or using FreeBSD to control some machine that you have. It's using FreeBSD in a product that you sell to customers, embedding FreeBSD into the product, if you will. So generally, when you develop a FreeBSD-based product, you install FreeBSD, you do stuff, and you deploy this product into the field, time passes, and you need to update FreeBSD for some reason. To take advantage of new hardware, to take advantage of new features, maybe to fix some bugs that you've encountered. So what do you do? So what you do may depend on how you're using FreeBSD in your product. There's a number of different ways to work or to integrate BSD into the product. Sometimes you're able just to take the binaries from freebsd.org, install them, configure it, maybe add your custom software, and ship it. That's the easiest case because there's no changes. You don't have to track anything. When it comes time to do an upgrade, you just grab another version. Sometimes FreeBSD doesn't quite meet your needs. You might need to have some local changes. In the simplest case, they're just bug fixes. They don't interfere with anything. In the more complicated case, maybe you need to rework the scheduler, rework the network stack, rework the VFS layer, do something major and intrusive in FreeBSD to make your product successful. So the amount of change and the number of changes you have would also dictate the methods that you would use in tracking or in keeping up with FreeBSD in your products. So before I get into all those methods and things, I need to talk a little bit about how the FreeBSD project is organized. A lot of you probably know this, but there's a main development branch called current. Everything goes into current and then is merged into a stable branch. Every so often, current is branched to create the stable branch, and then releases that go through a full QA cycle are released from this stable branch. Once we have a release, QA continues, major errata and security issues will then be patched against that release. So there's a whole continuum of code maturity from pure green code that goes into current to tested QA'd code that has been verified that goes into the release, to the errata that is gets even higher scrutiny that goes into the errata branches. This just talks about how code goes in to the current and then is merged after it's had a chance to go from being green code to being mature code. Sometimes code that goes in is perfect the first time. Other times, unforeseen problems come up. Maybe the original author was a little sloppy or didn't have all the right environments to properly test the code, which is why we have the kind of the current sandbox, so that there's a chance for these things to mature and the code to get better before it appears in a release for our users. How often do we have releases in the project? Well, in theory, we have them every 18 to 24 months, with each branch being active for about 2 years. For releases, their branches tend to be active for about a year after their last release, still getting bug fixes. Although there's a gradual reduction in the number of fixes and the size of the fixes that go into branches as the branch ends or nears its end of life. The theory is that we only have one stable branch and one current branch, except right when we're doing getting ready to and have just branched the new stable release. We do this from a resources point of view for the project. It's very resource intensive to maintain multiple branches. The project has limited resources, so we try to deploy those resources strategically to give, our users the best, highest quality software. So here's a graphical representation. If these are changes going up this axis, as time goes on, we have the change that goes into the current release. We cut a stable branch about every 6 months. This is years down here at the bottom. And they end rather abruptly after 3 years. As anybody that's been involved in the project for a long time knows, the reality is a little bit different. Major releases haven't been perfectly spaced through the span of the project. I'll show you a graph in a moment that illustrates this. Branches can live for a long time. I think we've had 2 branches that have died after only 3 years. Most of them live much longer. Some branches seem to be better than others. The 4.x branch lived for many, many, many years and got a lot of attention. The 5.x branch, the very next one, died fairly quickly, didn't get that much attention after 6.x was branched. Also, in the theoretical, I showed a nice steady progression, but code freezes and other events cause pent-up demand. So the graphs tend to flatten off near where we do a branch and then spike up after we do a branch as people that save code that isn't quite ready for to be released wait until after the branch point to commit it. And on the average, if you look at it and count the number of releases and divide, the 15 years that we've had of the project by the 6 releases or the 8 releases we've had, it's about what theory should be, but not exactly. And finally, graphs can be misleading if you don't include all the data, and I'll tell you what that means here in a second. So I have a little script that goes out and counts the number of changes that are in the project. So you'll see this graph up to about here is showing a nice exponential growth rate and then flattens out. I'll get to why that is in a second. But we were releasing cutting branches fairly good here and here, here. This is a little far apart. This is a little close. But then we had 5.x where we attempted to do S and P and G. And it's really obvious that we had bit off more than we could really chew because it took us a long time to do that branch. And then again, 6 was relatively quickly because people wanted to run away from 5 as quickly as they could. If you've used FreeBSD 5, maybe you can understand this. We had a good period of time between 6 and 7 and 7 and 8, and we were able to roll in a number of useful features in both of those releases. Both of the series of releases turned out to be fairly good releases. One thing that, when I just had this graph in a previous version of this talk, people would say, oh, well, your FreeBSD's dying. It's flattening out here. You know, how do you account for that? Well, the project actually isn't dying. If you graph all of the commits in Subversion, it shows a decent linear growth. It's not flattening out at all. But we adopted Perforce, where a lot of the development happened in kind of this side tree. And if you graph that, it still looks mostly exponential. There might be a little flattening out here. But at this point, I can't get additional data. The project has switched to using Subversion, and it's a lot easier to do your private work in Subversion branches that aren't even connected to the project, using SVK or using Git SVN or using the Mercurial gateway. So we're missing some data up here that would show that this, is still growing nicely. So I'll talk a little bit about the product life cycle, but it basically repeats what I had talked about earlier. You import FreeBSD and other software, you configure it, you modify it potentially, maybe you develop applications and you release the product. And sometimes you release the product, there's no market, game over, you go home. It doesn't matter what you did. There's going to be no pain for you in the future except finding your next job. Other times, you put it all together, you release it into the marketplace, it catches on fire, and everybody wants it, everybody wants the next generation. Now what do you do? So you have to start thinking, well, gee, we need to support new hardware, we need new features, all the reasons I said that you would want to upgrade FreeBSD in the first place. In a lot of ways, developing software is like herding cats. Trying to keep all the cats together at one time is very difficult. And I found this cartoon years ago where this cat herder is musing, I'd rather be managing a large software group, so it must be hard. So the problems with upgrading is a lot of people don't tend to think about upgrading when they do the first version. The first version's easy. You do all your thing, you ship it out the door. You don't really have to worry too much. You could do it perfectly and have no pain upgrading, or you could do it just the absolute wrong way from an upgrade perspective that it'll take you forever to upgrade. And you won't know until you have to do your first upgrade. So as you're moving from version to version, you have to forward port your local modifications. This talk is focused on FreeBSD, but the local modifications could be to anything. It could be to the Apache server. It could be to all the way to custom programs that you've written from scratch. You may also have bug fixes. You might have found that some edge case in some libc routine that your code depends on that FreeBSD got wrong. So you put a code fix in. The problem then becomes, once you've decided to upgrade, how do you manage this change? How do you sort out the changes that are incidental, like the bug fix to a libc routine, from the changes that are really your bread and butter, that maybe you went in and modified the scheduler to make your application perform better? Some of these might be useful to get back to FreeBSD. Some of these will probably port more easily than others. You really need to figure this out when you're upgrading. And that's the time when you go to do the first upgrade that you discover, oh, we did these things wrong, it's going to be really hard to do, or hey, we got lucky and did all these things right, or we had good people and they knew the right things to do. I've already talked about why to upgrade. I'm not going to talk about it again. But the thing that caused me to create this talk, to write the paper that goes along with it, I kept hearing about the bad FreeBSD experience. You imported the code of the product, you hacked on it for 6 months, you put it out, everything's great. Now you need to upgrade to get support for new hardware, new architectures, new devices. And for a while you can get by with just pulling that stuff in from FreeBSD, but the farther and farther you go, there's more pent-up demand. And when you finally have to jump to the new version, if you're on FreeBSD 3 and have to jump to FreeBSD 6, that could be a very painful upgrade. People have had to do that. You might laugh, but it wasn't very funny to these companies. I laughed too. So, what do you do to make this less painful? Well, first of all, you go out. You should go out and look in the community and see if anybody's cataloged all the ways it can be painful, and learn from their misfortune. Another thing that that people don't always realize, because it's not the way that traditional proprietary operating systems or proprietary systems in general operate, is that you can leverage the community in a lot of ways that you might not think to leverage a vendor that you currently have. And in general, bug fixes aren't a competitive advantage. There's some managers who think every single change, every single nickel that we put into the software has got to be a competitive advantage. And it turns out that if you have to carry forward a bug fix, well, somebody has to bring in the patch and look at the patch and make sure it applies. And if it doesn't apply, they have to move things around. And pretty soon you're spending a lot of time just carrying forward these bug fixes that don't really add any value to your product. If you fix a bug in Sterlin, but your product is all about switching packets through your appliance, nobody's going to, the competition getting that Sterlin fix isn't going to be any closer to moving more packets through their box than you are. So there's some bug fixes that are just not a competitive advantage. So there's a number of different tracking options that you have when you're tracking FreeBSD. And these apply to most other projects as well. A lot of other projects have a similar model to FreeBSD. Some of the details might be different. You might need to tweak it to work with these other projects. But the model that FreeBSD has developed is one that a lot of other software projects use. So there's 4 basic options that I've seen used. And most of the things are a variation on one of these 4. One is where you grab and go, you grab a release and go with it and then upgrade. And for people that have few changes or mostly just configuring it or adding on their own software that is just built on top of FreeBSD, that might be a good option. Another option, a little bit more complicated, is to try to track the FreeBSD stable branches. So you would import 8.0 when it comes out. You would make your changes to it locally. You would import new changes when 8.1 comes out, or maybe incrementally along the way. And that way you fly along in formation with what FreeBSD is doing. That makes it a little easier to give back to the community. And it also gives you the opportunity to keep your changes small. Another process that developed in the 5.0 time frame, when people were waiting for the 5.0 branch, was to track the current branch and decide when you think it's stable, make your branch, do your testing off of that. And then there's the strategy where we'll just grab it, we'll do our stuff, we won't track anything at all, and then 3 years later, we'll see what it takes to port to a new version. And that's something that I would hope you would decide not to do, because everybody that's tried that has not fared very well. The grab and go approach is you grab a version of FreeBSD, maybe you make changes, maybe you configure it. You never upgrade or participate in the community. It's easy to understand. It's simple. You know, it's so simple you can explain it to your management. And I have on here a pro that there's no interaction with the community. Sometimes interactions with the community can be painful. Usually not, but you know, sometimes there's individuals. Me sometimes, maybe. I don't know. The drawbacks are if you ever find yourself needing to upgrade and you've made a lot of changes, upgrades can be hard. FreeBSD sometimes is really good about keeping APIs stable, sometimes less good. If you're talking on, if you have, for example, in FreeBSD 3, serial devices had one name. In FreeBSD 4, they had almost the same name. Usually your code would port. In FreeBSD 5, they were changed. And then in 7, they were changed. I don't think they changed in 8. I can't remember when we retired SIA. Was that in 7 or in 8? But regardless, hard coding the device name for the serial line you're opening would cause problems. You know, just even if that was your only thing, that would cause problems. Also, if you're grabbing and going, it's difficult to add local changes, but it's difficult to keep local changes around. And as FreeBSD grows and evolves, and as all the creative effort of the FreeBSD community goes into it, those new features aren't reflected in your product. This is particularly a problem if you need to upgrade from single processor to multiprocessor, you know, from the last generation of multiprocessors up to Nehalims, what have you. Also, the network drivers. If you try to buy hardware that has network cards built in, they're always changing those chips out. You get a better performance, a cheaper part, better integration, fewer chips, whatever the reason for upgrading. Hardware tends to churn a lot, and if you don't have a newer version, you have to backport. And the cons are that there's no interaction with the community, because oftentimes interacting with the community can be useful. They can help you solve problems. They can maintain your code for you if you ask them nicely. So, you know, interacting with the community can be a double-edged sword. But on the whole, I think it's a net positive. So there's a variation on this called grab and upgrade. And this is what I was talking about earlier, where if you can install it, not modify it, and do your product on an unmodified version, the next version that comes out is probably going to be an easy upgrade. There are exceptions, but in general, it works out okay. Again, same pros. The only cons of this is that you have to upgrade because new hardware, new hardware happens. We have a very churny industry. So the next way of tracking FreeBSD is to track the major branches. And like I described earlier, you import it into a local source code management system. You make changes to the local source code management system. You merge in new minor releases, and that way you're able to evolve your product for the life of the branch. This lets you do this for several years without having to jump to a new branch. New hardware support is integrated back in. In this model, each major branch would have their own, I guess you'd call it a repository or its own branch in the SCM. This depicts it graphically where, I guess you can't really tell the green from the black on this slide. But this is green and that's black. Black is the FreeBSD community, what they're what they're doing. So you would, this just shows graphically where you import it into your code, you make changes, you pull new sets in, and you basically have your own customized version of FreeBSD 7 or FreeBSD 6 or FreeBSD 9. So if you track the major releases, you can bring in FreeBSD bug fixes. You can bring in new hardware support. It's a lot easier to push fixes upstream, particularly when you're in the early part of the branch. When you're in this part of the branch, it's really easy because the difference between this part of the branch and current is still relatively small, so your patches will apply. The further out you get, that advantage starts to dissipate as the changes get larger in current, or can, depending on where in the system you made your changes. Also, the FreeBSD project, when it's making the branch, does a lot of QA on the branch. So you're able to leverage the effort of the community to make sure that the branch is in a good, stable spot, particularly at the release points, that you would not have otherwise if you based it on some other point in the tree, that's another method I'll get to later. The disadvantages of this are that you can have multiple branches going at one time. If you have products that live for 5 or 10 years that you need to do maintenance on, and you based it on an earlier release of FreeBSD, you might have some additional overhead to do that. Since you're doing a separate repository or a separate branch for each major release, your source code changes aren't automatically brought forward. And finally, although we've gotten really good recently, major releases aren't completely predictable in the project. So the other method is mirroring FreeBSD's development process. And that's described as this diagram that's also green and black that you can't tell the difference between. But this is FreeBSD's development. This is the company's development. This is FreeBSD current. And so you import often from FreeBSD current. You also push your changes back in as quickly as you can for the changes that aren't your intellectual property. And that keeps these two lines from diverging too much. The advantage of this is you can say, now is a good time for me in my business to have a stable release. I'll cut a stable release here. Or I'll cut a stable release here. And this graph shows FreeBSD cutting it at a different time. So the advantages to doing this is that if you're continually updating current, you're continually updating your product. And it's very easy to merge changes in both directions. Your customized FreeBSD code base is relatively close to standard FreeBSD. So the changes that come in incrementally are easier to manage, easier to deal with. It's more of a continuous level of a small amount of pain rather than a huge amount of pain when you decide to jump major releases in some of the earlier methods. You can have a lot of community involvement. You can have them, you can engage the community a little bit more easily to help solve your problems. And you get to decide when you think it's a good time to cut a stable branch. The disadvantages, however, of doing this are that by cutting your own stable branch, you're duplicating the effort that the FreeBSD release engineer does. You're not leveraging all of that work into your product. Your internal branch will get less testing. Potentially, it will be less stable than if you had based it on a FreeBSD branch. And if you create these stable branches at odd points, and they live for a long time, it grows increasingly more difficult to get help from the community. You'll see mail to FreeBSD current from time to time saying, we branched from FreeBSD in 2008, and we're having this problem under load where sometimes weird things happen. Maybe it panics, maybe the network card stops for a second, maybe something else. And you do a little bit of digging and you find out that maybe this problem was fixed, maybe it wasn't. But since the people having that problem are running such an old release of FreeBSD, or not even a release, just an old snapshot of stable or of current, that it becomes very difficult to say, well, I think some of that was fixed or not, and it becomes difficult to track down the problems. And you don't know if it's a problem they introduced with their changes, or if it's a problem that nobody's encountering today because it was fixed a year and a half ago, just after they did their branch. This process is difficult to make work. There's one company I know that has made this work, and that's Ironport. But even they abandoned it, I think, with starting with 7. They started going to a branch each major release, track the stable branches that I talked about. And then there's the major porting effort, which is on here. It doesn't seem like a good idea if you think about it from what all the implications are, but a lot of short-sighted management decisions can cause you to get into the situation where you start with something, you hack on it, you produce a really good product, you sell the product as long as you can in the marketplace, and then you realize one day I have to upgrade. And then there's much pain and suffering. So those are the different options, the different ways people have tracked the project in the past. A lot of times when I've given this talk prior, people said, well, how do I deal with this? And John Baldwin wrote up using FreeBSD with Subversion and SVK. And so I'll talk a little bit about what he wrote up. I have a URL that points to his write-up as well as a resource for people that are interested. So SVK is a distributed source code control system that's written on top of Subversion. It's designed so that you can have detached operations. At the time it was written, it also offered improved merging because it would keep track of all the merges. Subversion has since grown that, so that's less of an advantage. One of the big things, though, is that you can import from FreeBSD a snapshot of FreeBSD current, FreeBSD stable, what have you, and then use that as a local Subversion repository. So these are the commands to do that. Once you've created the repository, you need to create a branch. And you use SVK to manage to manage when you're doing the merges from the mirror to your customized version of FreeBSD. Yeah, this just runs through the different levels on how to do the different steps. I think I'm gonna skip over that. Mostly because it's in the slides and people can go out and read the slides, or they can read John's blog, which is here, and also this is a tutorial on SVK here. So that ends the prepared part of my talk. Again, these are the URLs for the paper and the slides. The paper has some additional pointers for using additional SCM tools for dealing with some of this complexity. I guess at this point, I should open it up for questions. Okay, I guess there are no questions, unless I'm missing. Oh, yes. Oh, sorry.
Werner, do you think that you could list as another cons for the merging case with the current FreeBSD, the necessity to have at least, even if not a developer, between people you have in the company, someone that can deal very well with the current and that can put patches upstream easily?
Yeah, that's that's a very good point. One of the things that helps make this a successful model is if you have a FreeBSD committer or you have a good relationship with a couple of committers so that when you have patches and changes, you can work with the community to get them integrated. One of the advantages to frequent integration like that is you no longer have to maintain your bug fixes or maintain your changes. The community starts to do that. They won't mysteriously break when APIs change. If they cause problems, you get more people testing them to make sure that it's good. One of the things that this talk is too short for is kind of outlining all the strategies you can use for working with the community. That's would make a long talk in and of itself, and somebody should do that, and maybe I will.
That would be great.
So Werner, which of the methods would you recommend?
The methods that I've had the most success with have been the tracking the stable branch, where you import the stable branch often. With a slight variation, you keep a patch set against the stable branch that you then apply to current from time to test things out. Most companies that I've worked for generally have a little bit of downtime from time to time that I could try at least the critical patches out to see if there were problems. One of the things that I had management support for was as the patch set grew, saying, oh, this is getting too big. What can we push back into FreeBSD and maybe get merged back into this branch before we do our next snapshot so we can start to reduce the size of the diff. So that's the method I've used when I've needed to make large changes or medium-sized changes to FreeBSD. The other method I've used when I've not had to make any changes, where I'm just layering different products on, layering different packages on, is just the grab and go. You know, somebody else has built it all. I just use everything as packages. And then when I get new hardware, I grab a new release and put that on, put the new versions of the packages on, reconfigure, make whatever tweaks to the different config file changes, format changes for FreeBSD and the packages, and go. So a lot depends on how extensive your changes are, which method would be best.
Yeah, because I tried few things with my customers, and actually all of them have some cons. And basically, tracking stable branches, if you have significant local changes, it's quite okay, but only through the life of the stable branch.
Right.
When you switch to another major branch, there is huge porting effort to move the changes to the new major branch.
Right, and that's true regardless. I mean, that's one reason I suggest trying to also track current.
Which is very risky.
Which is very risky and very difficult, and you would never base a product on it, so it doesn't get the testing. I mean, there's a lot of reasons. Even if you could just compile test things on current, that helps a lot.
Basically, this led me to into thinking that maybe we as a project are not very friendly to companies. Maybe we can change something with in our development model.
I think you're. I think you. I'm a very sympathetic. I'm very sympathetic to that point of view.
I have no idea, so I'm just saying the cons. So.
Right. I'm very sympathetic to that point of view. Also, there have been some efforts to try to figure out ways to make the porting more automated, so that when you would jump the branch, if you used SVK to track the branch in the first place, you can use the merge information that you've accumulated to merge your changes then into a branch you create. If you had been tracking 6, you create a branch off 7, you could automatically merge all the changes in. But the problem with that is as software evolves and things change, the chances of just merging the changes in automatically are lower. So you have to do something to do it more incrementally, because between major releases is a very big jump, and if you jump over a major release, that's just a huge jump. And that's just inherently hard.
Because in the past, we had this problem that the current was very unstable, especially in 5.x days.
Yeah, that's why we started Perforce.
Yeah, exactly. So basically, because the easiest way probably will be for the companies, if the project would cut releases from the current branch, so we don't create stable branches at all. So we can incrementally track all the changes. Although our current is probably not as stable still as we would like. So this
right. OpenBSD uses a model very similar to that, where they have one branch, everything goes into it, it's always perfect. Just ask Theo. I promised I was not going to be catty today. Oh well. And so that branch works okay, but the complaints that that people have are that there's still too many API changes, and there's still too many. Sometimes it's unstable, so it's just hard to track even that model. So while it seems like it might be a good idea, the OpenBSD experience suggests that we should approach that with some caution if we wanted to try to change things.
Yes, because on the other side we have commercial vendors like Sun Solaris. If you look like with a declared stable, let's call it stable branch, Solaris, and lifetime of 10 years. And the question if that's a good way to go, and their development branch looks like, I don't know how.
Well, but the Solaris model is, if you're a customer, the Solaris model is very good. They work very hard to not change APIs, not change ABIs, to make sure that it's very easy to upgrade. But they pay a lot of people a lot of money to maintain the multiple branches. For people that don't want to upgrade from Solaris 2.8, that they just need this one fix, they have a whole organization that deals with that. They have a whole organization that can do the API and ABI testing to make sure that Solaris 10 or 11 or whatever they're calling it now, Oracle 12. Oh wait, they can't call it that.
It's coming. They're going to merge the operating system and the database engine.
Yeah. They'll throw out ZFS and just use the database engine for files. Hey, it makes sense to management. It's got to be good then, right? But the project really doesn't have the resources to devote to all of the, to devote all that engineering effort, which is effectively duplicated effort from a project's point of view. We have to do the same thing 7 times. That's not a very efficient use of our resources. It dilutes them by 1/7. Sun has made enough money over the years that they could pay a bunch of people to do that. Other companies have even worse branching issues, particularly if you notice Cisco's branching. And they're able to sustain and support that because of all the money that's coming in to do that. The project, for better or for worse, doesn't have a huge spigot of money coming into it. So, there are trade-offs there. Other questions?
Okay, if not, thank you very much for your presentation.